Okay, we are going to pick up here by talking about power. So remember, you guys, work is the force applied over a certain distance. Power is the rate at which work is done. So anytime you're talking about a rate, you're talking about how fast you do the work. So you're comparing the amount of work that's done to the time that it takes. So the equation that we're going to use is power equals work over time. So P equals W over T. But remember, we just learned that work can be force times distance. So we might also use the equation that power, P, equals force times distance divided by time. The units of power are watts. And you might have heard about watts with like light bulbs, like a 30-watt bulb or a 60-watt bulb. So when we're talking about power, we're kind of relating that to energy. So really, power is kind of like how much energy does it take to do this job? Our work is going to be in joules, and then the time that we're going to use to measure is in seconds. We're going to jump right into a few practice problems. So we want to know how much work is done if a power of 100 watts is used for 3 seconds. So we're looking for how much work, but this equation includes power. So we know that we can use the power equation, and that we don't want to use our force times distance. So if work is equal to power multiplied by time, our power is 100 watts and the time is 3 seconds. So we can plug those values in, and 100 watts times 3 seconds is 300 joules. Again, you guys, with work, the units are kind of a little tricky on this. So we're going to need to add power to kind of our memorized units. So power is in watts. Work is still in joules. And then distance and time we've been working with all year. Okay, let's try another one. I want to know how much power is used when a weightlifter lifts a barbell with a weight of 1,300 newtons, a distance of 1.5 meters in 4 seconds. Okay, so my question is how much power is used? But I'm given 3 pieces of information. I'm given a force. Remember, weight is the same as force. 1.5 meters and 4 seconds. So I'm going to choose my equation that has those 4 variables in it. Power is equal to force times distance divided by the time. So I need to define each of those. Force is equal to 1,300 newtons. My distance is 1.5 meters, and it's taking 4 seconds. So 1,300 times 1.5. We want to make sure we're being careful in our calculator. So we're going to multiply the top first, and then push equal and divide by the bottom, the 4. So power for this one is 487.5 watts. Okay, guys, I want you to try this problem on your own. A 400 Newton elevator goes up 20 meters in 5 seconds. How much power is used? Okay. So in this one, again, we're given 3 pieces of information: a force, a distance, and a time. So my equation I want to use is power is force times distance divided by time. So go ahead and define your variables. Okay, so hopefully you pause the video for a moment. Force is 400 newtons and distance was 20 meters. And it took 5 seconds for that elevator to go up those 20 meters. So when I plug my values in, I end up with 400 newtons times 20 meters divided by 5 seconds. And my power is 1,600 watts. So it takes 1,600 watts of power to move that elevator up 20 meters. Remember, you guys, again, my units don't cancel nicely. And so this is going to be a situation where I need to just memorize those values. So you guys are going to work on a practice worksheet. The front is work and the back side is power problems. So make sure that you have your notes handy and that you're reading carefully and using units.